take a look at some more application problems with quadratic equation. Well, we're going to take a look at some word problems that involve geometry, and in particular Pythagorean theorem and some border problems. Well, in this particular problem, we have the hypotenuse of a right triangle is 13 centimeters in length. So usually the hypotenuse, we label it at C, is 13 centimeters in length. One of the sides, let's say the second side, is 7 centimeters more than the third side. So let's say this side is 7 centimeters longer than this one. Well, how would I express that with expressions? Well, let's say that this side is B and this side is A. The side that we would label as A, we know is 7 centimeters more than B. So we could write it as B plus 7, because it's 7 centimeters more than B. Well, we are asked to find the length of these two sides. Well, let's remember what does Pythagorean theorem establishes as a relationship between the two sides that form the 90-degree angle and the hypotenuse, which in this case is C, or 13. Well, we know that A squared plus, and my pen doesn't want to work right now, so A squared plus B squared equals 13 squared. Well, we know that A can also be written as B plus 7 squared. So B plus 7 squared plus B squared equals 169. Well, now what I want you to do on your own is to expand this perfect square. Remember, it will expand into 3 terms. It will have 3 separate terms plus B squared. And ideally, you're going to want to eliminate 169 from the right side and make it appear on the left side to have the entire equation equal 0. You can do this on your own as we're trying to set up as many equations as we possibly can. Let's look at the second one. It says the hypotenuse of a right triangle is 25. So my C is 25. Now, the sum of the other two sides is 31. So I have my A, I have my B, and I know that A plus B equals 31. Now I also know, conforming to the Pythagorean theorem, I know that A squared plus B squared equals 25 squared. Now what I want you to take a look at is at the two equations, and hopefully you remember our unit on linear systems. We have two different equations with two different variables. One equation is a linear equation with exponents 1 for A and B, and the second one is a quadratic equation. So in linear systems, we learned that whenever we have a system of equations, one of the methods was called substitution. And we were expressing one of the variables in one equation and then substituting in that second equation. Well, what if in this first equation we say that A equals 31 minus B? Well, I could use that value and substitute it back into this equation. So I could have 31 minus B squared plus B squared equals, well, 25 squared is 625. So 625. And again, remember, the perfect square will expand into 3 terms, and then you collect like terms and solve for the possible B values. Let's look at the third problem. We have a garden that measures 8 by 12 meters. Quite a big garden. the area will be doubled by adding a strip of uniform width around the outside. So we're told that the area of the garden will be doubled. So before anything happened, the area of this garden was 8 times 12. Well, what is 8 times 12? It is 96, do not forget your units, meters squared. Well, if I am to double this area, I will get a bigger garden that's gonna measure 192 square meters. And I apologize, my pen is not working all that well right now, so it's producing all sorts of squiggly lines. So 192 square meters. Okay. Now we are told that the garden is enlarged by adding a uniform strip all around. Well, if it's of a uniform width, right, all these sides measure, let's say, x meters. All of them have exactly the same dimension. So the new area of the garden will be 192. However, the length and the width have been modified. So we have to think what is the new length and what is the new width. Well, let's look at the length. Before it was 12 meters. However, since I'm adding that border all around, I'm adding 1x to the bottom and 1x to the top of the garden. So how many x's in total? 2 x's. To the width, it was 8 before any modifications were made. However, I've added 1x to the left of the garden and 1x to the right of the garden. How many x's in total? 2 x's. So what are you left to do right now? You have to simplify by multiplying the two brackets, collect like terms including the 192 on the left side of the equation, and solve by either factoring or using quadratic formula.